Bismillahir Rahmanir Rahim. Assalamu alaikum students. This is Hamza Noor, and in this particular video I'm going to solve the question number 6 of International A-Level Edexcel P3 January 2022 paper. So it says that the function f is defined by fx is equals to 5x minus 3 divided by x minus 4, where x is greater than 4. Here we have a restricted domain. So in part A, the requirement is to show that by using the calculus that f is a decreasing function. So as you know, the fact that f will be a decreasing function when f dash x is less than 0. So we need to show that f dash x is less than 0. All right. So since fx is equals to 5x minus 3 divided by x minus 4, so fx is given to you in this form u over v, where u is equals to 5x minus 3. So u dash is supposed to be 5 and v is equals to x minus 4. So therefore v dash is supposed to be 1. So as you know the fact that fx is equals to u over v, therefore f dash x will be equals to vu dash minus uv dash completely divided by v square. So this is basically the formula of quotient rule. All right. So f dash x will be equals to, first you have to write v times u dash. Okay, so this is 5 multiplied by x minus 4, and then a subtraction sign. Then you have u times v dash, which will be 5x minus 3, and then it is completely divided by v square, meaning completely divided by x minus 4 whole squared. So f dash x is equals to 5x minus 20 minus 5x plus 3 divided by x minus 4 whole squared. So therefore 5x and minus 5x are cancelled out, and minus 20 plus 3, this is minus 17. So f dash x is equals to minus 17 divided by x minus 4 whole squared. So here we have obtained the f dash x function. So now we need to show that, we need to make some statements to show that f is a decreasing function, meaning f dash x is less than 0 for all the values of x. But specifically in this case, we are dealing with x is greater than 4. As you know the fact that when x will be equals to 4, okay, so the denominator will become 0 and the function will be undefined. So strictly speaking, here we have a restricted domain that x is greater than 4. All right. So when x is greater than 4, x minus 4 whole squared is always greater than 0, which means that x minus 4 whole square is always positive. But in the f dash x function, we have minus 17 divided by x minus 4 whole squared. So minus 17 is basically a negative constant. So whenever a negative value is divided by a positive value, you will always get a negative value. You will always get a negative value. So here we can make a concluding statement that therefore f dash x is less than 0 and f is a decreasing function. F is a decreasing function. So this is basically the answer to part A. All right, so now let's move on to part B. The requirement of part B is to find f inverse x function, and you need to also tell the domain. Okay, in International A-Level Edexcel paper, specifically in P3, in which you are dealing with this chapter functions. So here you need to also tell the domain as well. You will have an independent mark for that. Okay, so whenever you are writing a function, you also need to tell the domain as well. So I'm going to erase the working of part A so we can make some space for solving part B. All right, so steps to find the f inverse x function. First of all, keep y is equals to fx. Therefore, y is equals to 5x minus 3 divided by x minus 4, and then this will be xy minus 4y is equals to 5x minus 3. So as we want to make x the subject of the equation, so we need to collect all the terms which are related with x on one side of the equation. So therefore, xy minus 5x is equals to 4y minus 3. So now if you take x as common, you are left with y minus 5 inside, and this whole thing is equals to 4y minus 3. Therefore, when x is made the subject, x is equals to 4y minus 3 divided by y minus 5. So now the last step would be, in place of x, you are going to write f inverse x, and in place of y, you are going to substitute x. So therefore, f inverse x is equals to 4x minus 3 divided by x minus 5. All right. And now you need to tell the domain of this inverse function as well. Okay. And as you know, the fact that domain of f inverse is basically the range of fx. So first I'm going to find the range of fx, and first of all I'm going to make a graph for fx. Fx is equals to 5x minus 3 divided by x minus 4. So first of all, you need to convert this into a mixed fraction. So 5x minus 3 divided by x minus 4, you need to convert this into a mixed fraction form. So first of all, what I'm going to do is take 5 as common, multiplied by x minus 4. So you will get 5x minus 20, but you need minus 3 over here in the numerator. So minus 20 plus 17 will give you minus 3. So you are going to add 17 to it, and then this will be completely divided by x minus 4. So now this one single fraction, you can write it as a sum of two fractions. So 5 times x minus 4 divided by x minus 4 plus 17 over x minus 4. So therefore x minus 4 and x minus 4 is cancelled out, and therefore function fx in a mixed fraction form is 5 plus 17 divided by x minus 4. So now this is the fx function. Okay, so x is equals to 4 will be an asymptote over here. And as we know the fact that the domain of the function is that x is greater than 4. Okay, so x is equals to 4 is a vertical asymptote, and y is equals to 5, meaning fx is equals to 5 will be a horizontal asymptote. Okay, because if you keep fx is equals to 5, okay, so the value of x would be undefined, you are unable to solve it. So therefore here we have two asymptotes like this. Okay, so the graph would be something like this for the restricted domain as specified in the question. Okay, so x is basically greater than 4. This is a domain. So now what would be the range of the fx function? The range of fx function would be that fx is greater than 5. So this basically becomes the domain of the inverse function. So therefore, domain of f inverse x, domain of f inverse x would be x is greater than 5. All right, so you have an independent mark to tell the domain of the inverse function. Otherwise, sometimes the examiner, gives two separate parts. In first part, you are asked to find the inverse function, and in the second part, you are asked to tell the domain. That is a separate requirement. But if there is no separate requirement, even though you have to mention the domain of the function. Okay, you have an independent mark over here. Two marks are for finding the f inverse x function, and one independent mark is to find the domain of the f inverse x function. Okay, so this was basically part B of this question. So in order to avoid any of these steps which I've just mentioned over here, alternatively, what you can think of as quickly as possible, that since f is a decreasing function, all right, and since f is a decreasing function, and the other thing is that the asymptote would be at x is equals to 4. okay, because x minus 4 is basically in the denominator of the function. So x is equals to 4 is an asymptote, and if fx would be kept equals to 5, okay, so this will be something like this. 5 is equals to 5x minus 3 divided by x minus 4, and when 5 will be multiplied by x minus 4, so this will give you 5x minus 20. So 5x and 5x will be cancelled out, and therefore y is equals to 5, meaning fx is equals to 5 would be a horizontal asymptote. Okay, so in this specific part, in order to avoid any time consuming attempts, you can also sketch the function like this, that x is equals to 4 is basically the vertical asymptote, and fx is equals to 5, meaning y is equals to 5 is the horizontal asymptote. And as you know the fact that f is basically a decreasing function, so therefore you can quickly sketch this graph, okay, as soon as possible. And then you will know that the range of the function is that fx is greater than 5, and since the range of the function is that fx is greater than 5, domain of f inverse will be x is greater than 5. But having said that, this procedure, this method must also be on your fingertips. You need to be able to quickly form a mixed fraction form in order to make the sketch of the graph. Here is the working for part B. Now let's move on to part C, and I'm going to erase this complete working in order to make a space on the same page. So we have a complete fresh page over here. So in part C, part 1, show that f of fx, meaning the composite function, which is also called as f square x. So show that f of fx is equals to ax plus b divided by x plus c, where a, b, and c are constants to be found. All right. So as we know the fact that fx is equals to 5x minus 3 divided by x minus 4. So f of fx will be 5 times fx minus 3 divided by fx minus 4. And now in place of fx, I'm going to substitute the complete function. So 5 times 5x minus 3 divided by x minus 4, and then minus 3. All right. And then it is completely divided by 5x minus 3 over x minus 4, and then minus 4. All right. So far we have obtained this thing. So now what we can do over here is that we can multiply the numerator and the denominator of this fraction by x minus 4. So this is supposed to be 5 times 5x minus 3 minus 3 times x minus 4, and this is completely divided by 5x minus 3 minus 4 times x minus 4. So far we have obtained this thing. So therefore we can say that 25x minus 15 minus 3x plus 12, this is completely divided by 5x minus 3 minus 4x plus 16. So therefore 22x minus 3 divided by x plus 13. This is f of fx, the composite function. F is square x, and it is in the form of ax plus b divided by x plus c. So therefore a is equals to 22, b is equals to minus 3, and c is equals to positive 13. All right. So this is supposed to be our answer to part C, part 1. All right, so now we have the last part, which is we need to reduce the range of this composite function, which we have obtained in part 1. So here I'm going to use the similar approach which I used in part B, which is to express this composite function f of fx into a mixed fraction form, such that we can sketch the graph for it. All right. So as we know that f of fx is equals to 22x minus 3 divided by x plus 13. So now I'm going to convert this into a mixed fraction form. So as you can see that the coefficient of x in the numerator is 22. So first of all, I'm going to pick 22, and then I'll multiply this 22 with the linear factor which is existing in the denominator. Okay, so 22 multiplied by x plus 13. So when 22 is multiplied by x plus 13, what do you get? You get 22x plus 286, but you need minus 3 in the numerator. Okay, you need minus 3 in the numerator after 22x. You do not need 286. So you need to subtract 289 in the numerator. Okay, and then it is divided by x plus 13. So now what you get is 22 times x plus 13 divided by x plus 13 minus 289 divided by x plus 13. So now you can see that x plus 13 and x plus 13 is cancelled out. Therefore, you can say that f of fx, when you have expressed it into a mixed fraction form, this is 22 minus 289 divided by x plus 13. So far we have achieved this thing. And now we can easily sketch the graph for f of fx. So as we know the fact that the domain for the fx function is that x is greater than 4. It means that the function fx can take inputs only which are greater than 4. Okay, so the composed function f of fx will carry the same restriction over here. Okay, so the domain of the composed function is either the domain of the first function or else it lies inside it. Okay, so this is basically the concept, but here you have just, this simple rule. This x is greater than 4 will become the domain for the composed function f of fx. So f of fx, the composed function, will also carry the same restriction that x is greater than 4. All right. So now here we have obtained the composed function f of fx into a mixed fraction form. So I'm going to erase the earlier working and I'm going to just make a sketch. All right. And then we will be able to find the range of this composed function f of fx. All right. And as we know the fact that this function would be undefined when x is equals to minus 13, which means that x is equals to minus 13 would be a vertical asymptote. It would be a vertical asymptote. And as you already know the fact that when the output of this function would be 22, so this 22 and 22 will be cancelled out, and therefore you will be left like this. 0 is equals to minus 289 divided by x plus 13. So when you multiply this x plus 13 with 0, it gets eliminated, and then you won't be able to solve this equation. Otherwise, if you see it like this, that x plus 13 is made the subject, this will be equals to minus 289 divided by 0. So you won't be able to find the value of x. This essentially means that y is equals to 22 is basically a horizontal asymptote. Y is equals to 22 will be a horizontal asymptote. All right. So here we are going to sketch the graph. And as we know the fact that x is equals to minus 13 is a vertical asymptote. Okay. And as we already know the fact that the domain of the composed function f of fx is that x is greater than 4. It will carry the same restriction as of the restriction of the inner function. The inner function is basically fx, and fx has a restricted domain. X is greater than 4. So what we are interested in, finding the output of the function when x is equals to 4. Okay, so what would be the output over here? Put x is equals to 4 into the composed function. So 22 minus 289 divided by 4 plus 13. How much is this? 22 minus 289 divided by 4 plus 13, this is 5. The output is 5 over here. And then, as you know, the fact that y is equals to 22 is basically a horizontal asymptote. So the graph would go something like this for this restricted domain. And as you know, the fact that x is equals to 4 is not included in the domain. So I have made an unshaded circle, meaning an empty circle over here. Okay. So this essentially means that y is equals to 5 is also not included in the range. Okay. So therefore, we are going to say that the range of the composed function f of fx will be greater than 5, less than 22. Since y is equals to 22 is a horizontal asymptote, the function cannot intersect this horizontal asymptote. So the function has to be essentially less than 22 at any cost. So therefore, our answer to part C, part 2 is that the range of the composed function f of fx is greater than 5, less than 22. But again, I would say that if you want to avoid these steps of expressing the composed function into a mixed fraction form, there's no issue in this. Your sketching should be, on your fingertips. You should be able to sketch the graph of 22x minus 3 over x plus 13 very quickly. As you already know that the domain of the composed function f of fx is that x is greater than 4 and x is equals to minus 13 would be a vertical asymptote because it makes the denominator of this function equals to 0. And the other thing, in order to, quickly find the horizontal asymptote, what you can do, you can keep the output of the function equals to 22, because if you keep the output of the function equals to 22, so 22 will be equals to 22x minus 3 divided by x plus 13. And when 22 is completely multiplied by x plus 13, so you would get 22x plus 286. Okay, so 22x and 22x would be cancelled out, and therefore you won't be able to solve this equation, right? So when the variable of x is basically completely eliminated, you won't be able to solve this equation. So this essentially means that when the output is 22, it will be a horizontal asymptote, meaning y is equals to 22 would be a horizontal asymptote. And in this way, you would be able to sketch the graph as quickly as possible without doing these steps of expressing the function into a mixed fraction form, which I have done over here. And you would be also interested in finding the x-intercept, and for that purpose you would keep the function equal to 0. So 0 would be equals to 22x minus 3 divided by x plus 13. So when x plus 13 is completely multiplied by 0, so 22x will be equals to 3. So therefore x is equals to 3 over 22 will be the x-intercept. So you can identify that x is equals to 3 over 22 is the x-intercept. So in this way, what I'm trying to tell you guys is that if you are not comfortable with the mixed fraction approach, you can also skip it. No worries in that. But I would personally recommend you all to do significant amount of practice of expressing these reciprocal functions into mixed fraction forms. Okay, so you need to be able to get comfortable with all the procedures which I've done. Otherwise, I've told you the alternative way. Without expressing the composed function into a mixed fraction form, you can still attempt this. And here, obviously, I have restricted amount of time in order to make these videos. Okay, so if you want more detailed explanations, you can contact me, as the students who have studied the complete P3 course from me in my online classes, they already know that we have done sufficient amount of practice for these type of questions. All right. So this was basically the question number 6 of International A-Level Edexcel P3 January 2022 paper.